this what this has to deal with?
Sorta.
These kind of confuse me.
So do you want to go over that last page part?
Yeah.
There's like a ranking.
Yeah.
This.
These I didn't know they weren't in the PowerPoint.
Stronger intermolecular forces will lead to a lower vapor pressure.
And then
Higher vapor pressure will lead to a lower boiling point. So give me those molecules.
the examples.
Yeah.
So CH4. And then CH3F. CH3I. And then CH3OH.
Okay. So let's draw them out. Normally she would have done this with you in class.
Huh?
Normally she would have done this part with you
Yeah.
guys in class.
That's okay.
Or something like that.
Okay.
Alrighty, so let's determine, is he symmetric?
Uh-huh.
Which would make him.
Nonpolar.
Which would mean what type of intermolecular force?
See, I'm kind of confused by those. Let me see. Because isn't there like 3 different kinds? London, dipole, and hydrogen. Oh.
I think them this way. I have a big sheet of paper I laid down. So it's kind of like a Hunger Games or Robin Hood kind of thing.
Yeah.
I have my dartboard. Everything has London.
Okay.
Like, everything does. Non-polar guys, London is its highest intermolecular force.
Okay.
Dipole sounds like polar. So all guys who are polar have at least dipole. H bond, it's when hydrogen bonds to fluorine, oxygen, or nitrogen. Fon H bond.
Okay.
So nonpolar. And if I shoot my arrow and I go through London, I only went through 1 layer, and London is its highest. It's its first layer I went through. If I shot my arrow and hit dipole, I went through 2 layers. I went through both dipole and London. It's the first one I went through was dipole. That's its highest.
Okay.
But it also went through London. If I shot my arrow through H bond, I went through 3 layers. I went through the first one I went through was H bond, but I also went through dipole and London.
Okay.
It's like a cascade kind of thing.
Okay.
If I get H bond, I also got dipole in London.
Okay. You know what you're saying?
That's what that is. So, since this is nonpolar, what's its greatest intermolecular force?
So London. Okay.
Okay, is this guy symmetric?
No.
No. Are there lone pairs in the central atom?
No.
Are there polar bonds?
I have to check, huh?
Yeah.
Okay. Oh, we did this. CH and CF, there is one CF. So it makes it polar, right?
Yeah.
So I guess, would it be H and dipole?
Is there an H bond in here?
Yeah. No.
No, there's a fluorine in here,
Oh.
but the hydrogen isn't bonded to the fluorine.
Oh, okay. So then it would just be dipole.
Mm-hmm. How about this guy? Is it symmetric?
No.
Lone pairs on the central atom.
Nope.
Is there polar bonds?
I don't know. Let me check. CH is not one.
Yeah.
And
we know that.
CI. Where's I? Right here. 2.66. That's not going to be over there.
Okay, so it means he's nonpolar,
Yeah, no.
which would make his highest intermolecular force.
Lent.
Mm-hmm.
What are they like used for? Like, what are these used for? Do you know what I'm trying to say? Like, what's the point of them?
The bonds?
Yeah.
It's how strong they are. How
These are like how strong each bond is. Okay.
the Londons are only so strong. Dipole are stronger.
Like the bonds
H bond.
between atoms? Wow, that's so detailed. Who thinks of this?
I don't know. Okay, this last one.
Okay, no. It's not symmetric, right?
Yep. Are there bone pairs in the central atom?
No.
Are there polar bonds?
No. Oh, let me check. CH is no. Do I have to check CO, huh?
Okay, yeah.
CO, yeah, is.
Okay. Which would make it at least a dipole.
Right.
Is there an H bond?
Yeah.
Yes.
With
that
OH,
makes
huh?
a polar, and it's also H bond.
Okay.
So the strongest intermolecular forces are H bond.
Why are they the strongest?
They just are.
Okay.
I guess maybe their electronegativities are really, I don't know, it's just strong.
Okay,
You know
so
that.
then.
So let's see, ranked following, so 1 is the lowest, 4 is the highest. So
Four.
intermolecular force, yes,
That would be highest.
Dipole is the second highest.
So then that one, yeah. Three.
Yep. So we have 2 nonpolars.
What does that mean?
The way we differentiate between them is by their molar mass. If it weighs more, it takes more, it has a stronger intermolecular force.
So I have to find its molar mass. So,
Does iodide weigh more than hydrogen?
yes.
Well, then I know this one's going to be greater.
Oh. Do you base it off of this, what she gives us, if it's bigger?
That's intermolecular.
Oh.
That's the
Oh, but I guess it would.
on just the
anyways,
periodic table.
grams, yeah. Okay. 2 and 1. Perfect.
Yeah. And so boiling point means kind of like, I think of it like the heat that's required to break the bond, or its boiling point, or to get it to boil.
Okay.
And so the stronger the bond, the higher the boiling point.
So would the H bond have the highest boiling point?
Mm-hmm.
And then the next, so it's the same, pretty much.
Yeah, these two are pretty related. Vapor pressure. The pressure, I guess it gets when it vaporizes, right? When it evaporates. So if it has a lower boiling point, it's going to vaporize faster.
Faster. Okay.
Good thing. Or it's going to have more of the pressure.
Okay.
And so, and then this one will be the next. Do you see a pattern?
Yeah.
Intermolecular force.
Goes with boiling point.
Yep, same, and then vapor pressure is opposite.
That's like when we did the electromagnetic wave. Do you remember that? On Alex, and it was like the same thing, kind of.
Ranking them.
Yeah, the kinetic energy and something else was the same. I don't remember, but
Oh, that's that chart.